And on to the second discussion as the entire nation waits with bated breath. Viewers, Chandrayaan 3 is all set for a historic moon landing tomorrow. We're in the final lap in the ride to glory with less than 20 hours remaining for the soft landing challenge. India and the world are hooked to Chandrayaan in eager anticipation for the success of the mission. The Indian Space Research Organization has shared
the few nations to have been able to actually land anything on the moon.
Everyone in India and also myself, we are all eagerly awaiting for tomorrow's event in the lunar orbit. And I'm sure that will be a success for the Indian lunar program. And I hear that it will function much longer than it was supposed to because some fuel was saved. And I'm sure this will be a very fruitful lunar program for India.
This mission, if successful, will lead India to become only the fourth country to achieve a soft landing on the moon, joining United States, Russia and China, and emerge as a space power. It will mark the genesis of India's renewed lunar aspirations. With the initial mission leaned on international partnerships for launch vehicles, Chandrayaan 3 marks a shift towards self-sufficiency. Chandrayaan 3 also can play a crucial role in India's quest to establish a sustained human presence on the moon. With a successful mission, India will become a hot choice amongst other nations to assist in lunar missions as well. But is establishing a human colony on the moon a possibility? Listen in to what former ISRO chairman had to say.
To create a human living conditions on the planet, on moon, is going to be extremely difficult. There is no atmosphere, there is no oxygen or anything. We had to derive it from the water which is present in the polar region. And again, the temperature extremes are very high. Radiation conditions are very severe. So under those conditions, to establish a colony is difficult. But robotic exploration of the moon may find priority in the days to come.
And let's begin with the visuals that have been sent in today by the Vikram lander. This is the picture of not just the Vikram, but also, in fact, the lunar surface that we can see. And this is from one of the cameras that's on board the Vikram that has been sent. It's a video that you can see very clearly, that shows both the moon and, of course, India's craft over there. Very, very big moment. This is pretty much the picture of the day because this is just showing the kind of anticipation that we have. We're so close to the moon. It's just 70 kilometers away. And, of course, the descent that takes place will be in a phased manner. There are going to be proceeding at actually a much slower speed of about 1 centimeter per second is what we understand. There's going to be two-way communication between the two, and Pragyan will be relaying all of its information to the rover, which will then in turn send it to the orbiter of Chandrayaan 2, and then from there to, of course, the Deep Space Network in Byalalu, in ISRO Center, where it will be monitored, is the final destination as well. The mass is 26 kilograms of Pragyan. It's one lunar day that it will last for. That is, of course, 14 Earth days. There are two payloads on board Pragyan itself. The dimensions of it, of course, are here in millimeters. It will, of course, be very, very significant that the communication will happen through that. And look at this. This is very significant. If you can just freeze that for a moment, look at the tracks that will be leaving behind through its wheels the imprint of the Indian national emblem, that is, of course, the Ashoka Lions, and, of course, ISRO as well. We can continue to play that. This is showing how it is going to traverse the lunar terrain. It will be able to climb small rocks and other obstacles because of the kind of suspension that has been given, particularly with this aim that wherever there are, in fact, rocks or some kind of trenches that it encounters, it continues to traverse that particular distance. Some of the payloads and some of the experiments are, of course, described in this, and this is pretty much the kind of journey that we expect. Let's quickly remind our viewers of the kind of journey that Chandrayaan has taken as well. Show that to you graphically before we go across to our experts. Very quickly, this is Chandrayaan 3 moon mission. Of course, this is the time of takeoff from Sriharikota. The LVM-3, of course, M4 vehicle is there. Let's go on further and tell you about its height. It's at 43.5 centimeters. The liftoff mass is 642 tons. The mass, of course, is 1749. Of course, the mission life is one lunar day, as we know. And in fact, this is the time when it blasts off into space. Of course, that's the takeoff there. We are, of course, we remember how it actually happened, where in fact these strap-on boosters move. Then there's further the solid propulsion module that also comes off, and then of course the orbiter, which finally comes out of this, which will orbit the Earth's surface, and that finally is what we are looking at. detaches, and then of course it goes in its orbit around the Earth's surface. It will slowly detach from that, and of course, as we know, there will be orbit raising maneuvers that happen. As you can see, around each orbit, the orbit increases until it finally goes from the Earth's gravitational pull to the lunar gravitational pull, and that's the slingshot, the Vikram lander. The dimensions are 2000 by 2000 by 1166 that we've been already telling you about. This is of course the communication through ISDN, through the Chandrayaan 2 orbiter, etc., that will be there. This is the landing site, and if you can go on further and describe all of the payloads, this is the Langmuir probe to measure the near surface plasma, ions and electrons density, and its changes with time. Let's go on and get you the next payload that's on board the lander. That is the Chandra surface thermophysical experiment to carry out the measurements of thermal properties of lunar surface near the polar region. So what really is the temperature, etc., all of those details. There's also an instrument for lunar seismic activity to measure seismicity around the landing site and delineating the structure of the lunar crust and mantle. What kind of earthquakes take place, what kind of seismic activity is there, is of course the third payload. Now we're looking at how, in fact, and we showed you earlier as well, how in fact Pragyan, the rover, comes out from there through that one wall that opens up and forms a ramp. And these are, of course, the details of Pragyan itself. It's one lunar day, that's the mission life, 14 Earth days, and it's very important that it lands tomorrow because then it can take full advantage of the 14 days of sunlight. The mass is 26 kilograms. That's the weight of the rover. The power is 50 watts. That's, of course, the solar panel that you see that's generating power. The payloads are 2 on board the Pragyan itself. The dimensions are 917 by 750 by 890 by 397, beg your pardon, millimeter cube. The communication is going to be directly with the lander itself. Remember, it'll have to communicate through the lander and go further. Now, these are the payloads on board Pragyan. Alpha particle X-ray spectrometer to in fact derive the chemical composition and infer mineralogical composition to further enhance our understanding of the lunar surface. There's of course another payload on the rover as well, that is a laser-induced breakdown spectroscope to determine elemental composition, MgAI, SiK, CAT, of course, elements that we all know in lunar soil and rocks around the landing site. That's as far as the LIBS is concerned. Let's quickly open this up, take it across to our experts joining us, also requesting our viewers to join us and call us in with your questions. First and foremost with us on the panel is Johann Dietrich Wörner, who's a former Director General of the European Space Agency, who's joining us live. With us is Manish Purohit, former ISRO scientist, who's also with us. And in fact, let me come across to you first, Mr. Wörner, and let me begin by asking you, at this moment, what's the excitement like in the space community? Because this is a once-in-a-lifetime moment, at least, that people in India are looking at. And of course, we know what unfortunately happened with the Russian mission. What are the hopes and what are the odds, according to you, of the success of Chandrayaan 3? Yes.
Yeah, hello. So it's not only an Indian excitement, it's an excitement for all space people, because the moon is an excellent place to go. The moon is interesting because of science, because of technology. It's also interesting because there is some water on the surface of the moon, we expect. And what is most important for me is that this mission is again a mission which supports the international collaboration with NASA, but at the same time with the European Space Agency through ESTAC. So I'm very happy that this mission takes place, and I cross both my fingers to success.
Manish as well. Manish, you know, the odds of success I was reading are somewhere around 53% when it comes to landing on the lunar surface. What are the odds of this particular mission? And do you think that we've really learned from whatever went wrong? I won't call it mistakes, but certainly, of course, it didn't happen as we quite expected when it came to Chandrayaan 2. Have we really done enough of provisioning and redundancies on Chandrayaan 3 to ensure that Vikram lands safely?
Yeah, actually, to begin with, we can call this as a failure-based design. Now, this failure is not about the failure in Chandrayaan 2. The failure here is keeping an account of what all can go wrong, what all things can go wrong, whether it's the thrusters or it's the orientation, it's about the onboard algorithm, decision making. So everything has been well tested, everything has been simulated, the algorithm has been very strictly tested on ground, and different tests have been done. If we go back and check what happened with Chandrayaan 2 and the data that we got from there, from the telemetry that we had, there are few things that started to go wrong when we were in the camera costing phase. That's the second part of the lunar descent. So after the rough braking, when we were in the attitude control phase, when we are in the camera costing phase, when we were clicking photographs of the lunar surface and comparing with the onboard images that we had, that time, we can say thrusters were not performing the way they should be, and the algorithm was not correcting those errors. So that is something that we have learned, that we should be doing the real-time check, and that's what we have done this time. And now coming to the next part, when that whole thing accumulated, all those errors accumulated, then we were not exactly where we were supposed to be. We were supposed to be somewhere at around 400 meters above the surface, but we were way behind our launching our landing site. We were around 850 meters behind, and we were 350 meters high above the lunar surface. And then the algorithm again did one thing. It was it was doing the counter, that how much time is left and what we have to do, and then it started thrusting the our lander, and we had that unfortunate event in Chandrayaan 2. Now, taking all that thing in account, few things that have been done is the camera costing phase that was 38 seconds in our Chandrayaan 2 has been reduced to 10 seconds, means we have sped up the calculation part, the sensing part.
Right.
And we have removed one of the engines. Right now we were with 5 there, now we have 4, so we have more possibility of carrying more fuel, and that helps us when we have to hover around the situation, because in this particular time when we'll be having the descent of our lander, Chandrayaan 3 lander Vikram, when we'll be at around 150 meters above the surface of the moon, then our hazard detection and avoidance camera will switch on. It will start taking images, and then it will tell us whether we have a go/no-go situation. Go situation means if everything looks fine, we'll go down, we'll cover that 150 meters in around 73 seconds. If it's a no-go, we have to move ahead some 150 meters and again try that.
Okay. And in fact, Mr. Johan Dietrich, if I can ask you, in terms of the actual scientific experiments, what really are we looking at over here? Because we all know that, yes, the South Pole and the big craters that are where we probably expect ice, expect water. Is this very significant from other scientific exploration missions as well, in terms of what we could possibly achieve? Perhaps many are talking about lunar colonies and how this could be seminal in those kind of constructions as well.
The moon is something like an archive of the Earth. The moon was established through an impact of another body with the Earth. And by that, the moon has no quakes, or not strong quakes. The moon has no flora, no fauna. So the moon is, let's say, a museum of our history. And therefore, we can learn a lot by investigating the moon. We can learn something about the Earth. And even more, as you mentioned, I'm asking and telling the story of a moon village where people from different countries and different nations and industry as well as public institutions should work together on the surface on the moon for research. And of course, they need water, they need oxygen, they need hydrogen. All of this might be found on the surface of the moon, and therefore this mission is one step further for international collaboration of a moon village.
Well, absolutely. International collaboration, of course, as we know, when it comes to space is so significant, because it's all about the entire humanity, the entire human race actually going to its own satellite. And let me take this across to our first viewer joining us. We've asked our viewers to join us. We have experts here who can answer your questions for the next few minutes, so don't lose this opportunity. Dr. Ramchandran is joining us from Chennai. Yes, Dr. Ramchandran. Dr. Ramchandran, can you hear me, sir? I think we've lost that line there. Let's go across to Akhilesh Chaudhary from Faridabad. Yes, Akhilesh.
Yeah, hi. Thank you for taking my question and inviting me. So it's really about great time for all of us being Indian, and great to see. And we are awaiting the news that will come tomorrow. And hopefully, we should learn from what happened in the Chandrayaan 2, and we should be able to land safely and making India proud. So thank you to all of us, and congratulations to ISRO.
All right, so those wishes coming in there, but specifically, I want you to take us through, Manish. What are we going to expect tomorrow? From 80 kilometers, it's going to make a rapid descent with a rough braking phase. Just describe the rough braking and the fine braking. What's the difference between the two? Because incidentally, it is a fine braking phase where things didn't work out for us. What really will happen?
The whole scenario will start somewhere around 2 hours before when we'll start the power descent. because the whole situation is like that. Once we commit, once ISRO commits that yes, right now we are going for the power descent, then there is no way coming back. So that decision will be taken around 2 hours before. We'll say, okay, fine, now that's the time. We are right now 25 kilometers above.
So around 3:45 tomorrow, around 3:30, 3:45, that decision will be taken?
Yeah. So once
and there's a possibility it won't happen tomorrow also then. If they feel there is any kind of niggle, software, hardware, then it can be postponed by a few days.
See, actually, the thing is, such critical missions, we can't be, we can't be kind of adamant. If we have some issues, then we have second priority sites, and that will be available for us for landing on 27th. Roscosmos has kept sites for Luna 25. Unfortunate event, didn't happen that way. We all wanted to. So when we'll come back to our Chandrayaan, let's say we have committed. Okay, fine, this is the day, and we are going down. We are going to have a soft landing. So we will be around 25 kilometers high from the lunar surface, around 750 kilometers away from our destination. That time we will be, cruising at a speed of around 1.6 kilometers per second, very fast, very fast. But the situation is, we'll be moving this way, tangential, it's orbital velocity. So from this, we will have an intermediate position, and then we have a final vertical position. That time we will be hovering. Now you asked about, the rough braking and the fine braking part. The situation that went wrong during Chandrayaan 2 was neither rough braking nor fine braking, but the camera costing phase.
Okay. So the last phase.
No, it was the intermediate of
intermediate
the two.
phase. Okay.
So I'll take this as a prop, and this is our Vikram moving this way. Then after covering around 700 plus kilometers and bringing down the horizontal velocity to just say 1/3 of what initially it is, we will be in this particular situation. We call this attitude control phase. We control.
But it's moving from horizontal to vertical, basically.
So yeah. So it's like this. It has come down a lot. It has come down a lot also. It has come down, let's say it has come down to 1/3 of the distance, we can say. Now it is in this position, and at this point, in Chandrayaan 2, this was named as camera costing phase. Now we are calling it attitude control phase. So here we will be clicking images of the surface, comparing with the onboard cameras, or onboard images that we have, and take the next decision. Okay, fine, we are on the right track, we are going the right way.
We hope that camera coasting or the altitude control happens well, but stay with us. Just hold on to your thoughts, because several of our viewers are with us. Sushil is with us from Ludhiana. Yes, Sushil.
Hello.
Yes, Sushil, go ahead.
Sir, I want to congratulate our team ISRO, but I have been... Hello?
We can hear you, Sushil. Please go ahead with your question.
Sir, I want to congratulate in advance to the team ISRO, but I'm given to understand that landing is going to be as precise as it has been programmed. But I just want to... my question is, what if the plan A doesn't succeed?
What if the plan A doesn't succeed? Certainly, of course, then there is plan B. Of course, that's why there is a plan B. But thanks so much for joining us, Sushil. I'll ask that question nevertheless. Anand Deshpande is with us as well. Anand Deshpande from Nagpur, go ahead.
Sir, I want to say only one important thing, that the entire ISRO team, Moon team, has worked with their head, heart and soul. Success is going to be there. He should be given the highest presidential award, because they are bringing not only pride to India but confidence.
Well, certainly with the national pride, all the national accolades will also follow, sir, and certainly not just national but perhaps international ones as well. Thanks so much for joining us with your wishes all the same. Sushil is with us from Coimbatore. Yes, Sushil.
Hi, everyone. So I think it's going to be a proud moment for all of us, and with this mission, and hopefully I think it should succeed. So my question to the panel is that once the rover lands on the moon, so what type of experiments or what type of mission it is going to carry out on the lunar surface?
Yeah, we just in fact explained that in great detail. If you are watching this online, you can in fact rewind and look at the clips just a little ahead. But last question from Rajesh in Delhi. Yes, Rajesh.
Hi, hello. My question to the panelist. When the lander is in the last phase, the thrusters are pointing downwards. Suppose they don't find the proper place to land, then it has to move horizontally. How does it move when the horizontal speed is 0?
Yeah.
Thrusters are pointing downwards.
Okay, that's a very relevant question. I'm going to ask those questions across to our panelists. Mr. Johan Dietrich, one of the things that has come across is the challenge of landing on the South Pole. How difficult a task is this, and why? Mr. Dietrich, can you hear me? Mr. Johann Dietrich, can you hear me, sir?
Yes, I can hear you.
Yeah, one of the questions coming in is, of course, the challenge of landing on the South Pole. What if they don't find a good landing area? And how much of a challenge or a concern is this?
So if you look to the moon during night, you can easily understand why it's so difficult. Because if you look to the moon, you see flat areas, so very flat areas. This was where Apollo 11, for instance, was landing, and also all the first missions to the moon were landing. Now, if you go closer to the poles, or to the far side of the moon, it's a rough surface, a very rough surface. So you have to be very careful where you go down because you cannot land on a very inclined area. So therefore, it's challenging. So the whole mission is challenging, and this is very important. It's already a success to go to the moon. Now to go closer to the moon, another success. And if you succeed really to land softly on the surface of the moon near the South Pole, that would be really extremely good. So I cross my fingers.
Absolutely. We certainly wish Chandrayaan-3 all the success, and of course, not just a billion Indians, but in fact, billions across the world that are looking at the potential success and what this really means, because this really puts India in an extremely elite club of just 4 nations. And we certainly hope that ISRO, for all the hard work, all the blood, sweat and tears that have been put in, does succeed in this mission. I'd like to thank Manish Purohit as well as Mr. Johann Dietrich Wörner, former Director General of the European Space Agency, for joining us. And certainly do join us on our broadcast tomorrow. We will be, of course, covering this all day tomorrow here on Times Now. We'll be bringing you the best of analysis, global guests and experts as far as space is concerned, and of course bringing to you minute-to-minute coverage from the ISTRAC Center in Pune on the outskirts of Bengaluru, where all the action will be reported from. Thanks so much for joining us on the NewsHour Agenda this evening.
The News Hour at 10.